In this session, we're going to talk about the fundamental principles of counting and also using combinations. We're going to begin by the fundamental principles of counting, and it states by definition, the fundamental counting principle states that if there are P ways of doing one thing and Q ways of doing another thing, then there are P times Q ways of doing both things. Let's take a look at an example. Here it says that license plates in a certain state contain 3 letters followed by 3 digits. How many different license plates can be made? So the first thing we'll do is we'll map out the license plate design. So there are 3 letters and there's 3 digits. The next thing we'll do is for our 3 letters up front, we'll determine the number of possibilities. So since there's 26 letters in the alphabet, there's 26 choices for our first character. There should be 26 for the second as well as for the third. Next, we'll look at the choices of digits. So the digits are 0 through 9, which gives us a choice of 10 for all 3 remaining choices. Now, if we were to multiply all 3 together, we would have 17,576,000 choices of license plates. Right? And this is the counting principle. Next, we'll take a look at what's called a combination. And now, as far as a combination is concerned, here is the formula. We have the formula for a combination as n choose r, and that's equal to n factorial divided by r factorial times n minus r quantity factorial. Now, the exclamation that you see, that's actually what's called a factorial. Right? And here's how factorials work. For example, 4 factorial, that would equal to 4 times 3 times 2 times 1. So if we multiply 4 times 3, we get 12. 12 times 2 is 24. And 24 times 1 is 24. All right, so 4 factorial is 24. 3 factorial is 3 times 2 times 1, which is equal to 6. As far as our calculator is concerned, I'm going to evaluate these in the calculator. I'm simply going to turn on my calculator, and in order to evaluate 4 factorial, I'm simply going to hit 4. I'm going to go into math. I'm going to scroll over to probability. Right, my fourth option is factorial, and I have 4 factorial is 24. So notice that there are factorials in this formula. All right, so what is a combination? Well, when choosing a set of objects or an object from a larger set, when we only care about the objects that's chosen, we use a combination. So here is an example. It says 30 people attend a certain event, and 5 will be chosen at random to receive prizes. The prizes are all the same, so the order in which the people are chosen does not matter. How many different groups of 5 people can be chosen? Well, we will set up a combination. Well, we have a total of 30 people, and out of that 30 people, we want to choose 5. Right, so n is going to be 30 in our formula, and r is going to equal to 5. Right, so if I follow that out using the combination formula, we have 30 factorial divided by 5 factorial times 30 minus 5 factorial. Now I can actually calculate this up using factorials, but on the calculator, there is actually a combination key. So let's see how that works. So we have 30, choose 5. So I'm going to put in 30. I'm going to go into math. I'm going to go back to probability. And the second choice is our combination. Right? So I have in 30, choose 5. And we have the result as 142,506 possible combinations. All right, so here we have a total number of combinations. All right, now we're going to use these two concepts to answer some questions. Okay, in particular, this question, it says a coin is tossed 5 times. Construct a table given the number of heads that can occur, along with their associated frequencies and probabilities. We're asked to round to the nearest hundreds. Right, so as we look at the charts, in the very first column, we have the number of heads. The second column is the frequency, and the third column is the probability. So the first thing we'll do is we'll determine the frequency. And we're going to determine the frequency by using a combination. So we're given 5 tosses, and out of those 5 tosses, if we were to choose 0 heads, right? So for my first frequency here, I'm going to put in my calculator 5, right? Because we're tossing a coin 5 times. And out of that 5 tosses, we want to choose 0 heads. All right. And the frequency is 1. Right. So we're going to toss the coin 5 times. I want to observe the number of heads. So I get 5. Right, we're going to toss the coin 5 times, and we're going to choose 2 fours. So that frequency is 10. We're going to choose 3 fours. So again, that's a total of 10. Right, here we're going to choose 4 heads. So that should occur 5 times. Right, and lastly, if we want all 5 heads, that should occur once. All right, so I have our frequency by using combinations. Now, what about the probability? Well, for the probability, we would simply take that frequency divided by the sample size, or the entire sample space for tossing a coin 5 times, right? So we're going to map that out by using the counting principle. All right, so we're tossing a coin 5 times. One, two, three, four, 5. So for our first choice, there's only the choice of a head or a tail, right? So the choice there is 2, right? The choice is 2 for all 5 coin flips. So we have 2 to the 5th power, which is 32, right? So I'm simply going to take the frequency and divide by the sample space, which is 32, and that will give us our probability. All right, so for our first probability, we have 1 divided by 32, and that's 0.03. Next, we have 5 divided by 32, which is 0.16. Next, we have 10 divided by 32, which is 0.31. Again, 0.31. 0.16 from a previous calculation, and 0.03 from a previous calculation.